Hey guys, welcome again to the Maths Club. We are still on our series on set theory, and today we're breaking at some set problems. I know that we've been talking about operations, representation, Venn diagram, and all those things, so I feel it to be a good position for us to actually try some problems and apply some of the things that we have done so far. So let's get started. Before we begin, there are some important terminologies that we need to know. The first of which is when you see the word at least means a minimum of or not less than. So if I see something and say, oh okay, I eat at least 2 times a day, that means I eat a minimum of 2 times a day, right? That means I don't eat less than 2 times a day, really. If you see the word at most, so using that same example, if I say I eat at most 2 times a day, that means 2 or less, right? 2 or less, that means sometimes I could not eat, sometimes I could eat once, sometimes I could eat twice, but at most like the maximum allowable amount. The third is neither. When you see neither indicates that something does not apply to either of 2 or more things, right? So mostly you say, oh, I'm neither here nor there, meaning I'm just everywhere. So it indicates that something does not apply to either of 2 or more things, and is mostly used with no. The fourth one is when you hear the word either, right? Either indicates a choice between 2 options. So maybe your parents come to me and say, what would you like to eat? Would you like to eat either rice or beans, right? Most likely you'll choose rice. So either indicates a choice between 2 options. So before we go to the general equation, there's something I want to represent in diagram. So imagine we have this is set A and this is set B, and in between set A and B, this is like the intersection between them. So if this is set A and this is set B, and I want to find A union B, that is what is in A or in B, I could say this is what is in set A, right, plus what is in set B. Ideally, you think that this is what will happen. You say, okay, whatever is in set A and this whatever is in set B. But remember, there is a point where they intersect. So if our set A was, let's say, 1, 2, and our set B was 2, 3. If I wanted to find A union B, I would say A union B is, remember, there's no repetition, so that would be 1, 2, and 3, right? That means that you can see that I took out one of the intersections, right? So the intersection is meant to appear twice because there's no repetition. We take out the extra repetition. It is not 1, 2, 2, 3. It is 1, 2, 3. So that means that if I want to find the union of A and B, I'll say A plus B minus A intersection B. So this one will take out one of those things that join A and B, and this will give me the correct elements in A union B. If I wanted to find the number of elements, I could just come here and say, maybe after I finish listing it, I could say the number of elements in A union B. How do you represent number of elements? Most likely forgotten. We say n, so n in brackets A union B is equal to this A. I want to find the number of elements. I'll say n of A plus n of B minus n of A intersection B. So let's see, how many numbers are in A union B? 1, 2, 3. How many numbers are in A? 1, 2. How many numbers are in B? 1, 2. How many numbers are in A intersection B? So if I were to say intersection B, that would have been just element 2, right? So if I count it, 2 plus 2, that is 4, minus 1, that's 3. And how many numbers are in A union B? 1, 2, 3, right? 3. So this actually works. Again, if you want to find the union of A and B, you have to take out one of the intersections, because if you don't do that, you'll be counting the intersection twice, which we don't want. And if I have this one, I can just say n of, just put number of behind them, and then I'll get the same thing. Now look at this other example, and I'm going to use a diagram to illustrate it. So if our universal set was 1, 2, 3, 4, 5, and our set A is 1, 2, and our set B is 2, 3. If I wanted to find A union B, remember we said we could say A plus B minus A intersection B. On this universal set, we have 1, 2, 3, 4, 5. If I wanted to find A union B, but from the point of the universal set, what will I do? Let me remove this part that we already know. So I would say the universal set, the first thing I'll remove from the universal set is those things that are not in A or in B, right? So all the things that are not in A or in B, this 4 and 5. How can we represent what is not in A or in B? Great. Complements, use of complements. So I could say A union B complements. So this is like saying U minus whatever is not important. So by the time I subtract this guy, what will I have? By the time I subtract what is not in A, what is, let's even say what is A union B complement. First of all, we need to find A union B. A union B is 1, 2, 3, right? So A union B complement is what is in the universal set that is not in A union B, and that is what? 4 and 5. So 4 and 5. So by the time I take out 4 and 5 from this universal set, what I will be left with is 1, 2, 3. Great. So basically, this is like another representation of A union B, right? So either we work from what is in A plus what is in B minus what is in the middle, or we say the universal set, take out A union B complement, you also have A union B. So there's also something that we need to know, that in the previous time we said A union B. What do we say A union B is? We said it is A plus B minus A intersection B. So if this guy is equal to this guy and this guy is equal to this guy, do you agree with that these two guys should be equal? Right? So I could come out and say U minus A union B complement is equal to A plus B minus A intersection B. If any of this is looking very strange, please watch it again and follow it step by step. You can pause, you can rewind, and that's a good thing about YouTube videos. Same thing, so if I wanted to find in terms of the number of, I could just say the number of the elements in the universal set minus the number of the elements in A union B complement is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B, right? These are two ways that you can be able to find the same thing, and you will see the application in real questions. Let's go to what the general equation is saying. So it says for any two subsets A and B that are not disjoint, meaning that there must be a connection between them, that is A intersection B is not equal to the null set, the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus number of elements in A intersection B. And that's what we just finished explaining. So we have these sets, right? And then we have the second equation which you just got. I want to find the same thing. I would say the number of elements in the union minus number of elements in A union B complement is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. And you can see this, like this X here is the A union B complement, that is whatever is not in A union B is this X. So with this we can start solving some questions. Once again, if any of this is not clear, rewind and start again till you get it. So let's go to example 1. The first example says that in a science class of 42 students, each student offers at least one of mathematics and physics. If 22 students offer physics and 28 students offer mathematics, find out how many students offer both subjects. So one thing I really wanted to notice that first of all, they said each student offers at least one of mathematics and physics. That means that there might be points where they will intersect, right? Maybe somebody is studying maths and physics, right? In that sense, if some two students offer physics, so there's something that you need to know. So whenever it's this kind of question, if you don't see only, look at it, so this is different from if 22 students offer physics only. So in terms of the only I'm talking about, so if this is maths and this is physics, right? If they said number of students that studies maths is 25, what I'm saying is that it is this entire space. This entire space. But if you see, when they say number of students that study maths only is just this place. That means the one that don't study maths without studying physics with it. So you need to note the difference between mathematics and mathematics only, physics and physics only. Let's go back to the question. It says if some two students offer physics and 20 students offer mathematics, find out how many students offer both subjects. We're going to solve this mathematically, and we're going to use the Venn diagram to solve it. So what are we given? We're told that the universal sets, that means number of people in the class, so the N of U is 42. Each student offers at least one of these, and they said number that studies physics, so the number of physics is 22 and the number of mathematics is 28. So that's the find out how many students offer both subjects. So these are what we are given in the particular question. So let's see. Our formula, I'll use the second formula that we talked about. So N of U minus the N of P union M complement is equal to N of P plus N of M minus N of P intersection M. In this particular question, is there any possibility that the student does not offer physics or mathematics? Let's see. It says each student offers at least one of, so there is no student that will not offer at least any of them. So this guy is basically going to be 0, right? So I could take it out and we'll be left to just N of U. So it's like just saying N of U is equal to N of P plus N of M minus N of P intersection M, right? So we know the N of U to be 42, so that means this is 42. We know the N of P to be 22. We know the N of M to be 28 minus N of P intersection M. So 42 will be equal to 22 plus 28, that will give you 50 minus N of P intersection M. So let's create like terms. 42 minus 50 is equal to minus N of P intersection M, right? 42 minus 50 is minus 8, and this is like saying minus N of P intersection M. So if I divide both sides by minus, right, this guy will go, and then what will be N of P intersection M is equal to 8. So this is using our formula. If we were to use Venn diagram, how would we solve this particular thing? So this was our Venn diagram. Our U will be somewhere outside here, right, which is like the universal set. The U was given as what? 42, right? So U is 42. If this is our physics set and this is our math set, our physics set is what? 22. So P will be equal to 22 and M is equal to 28. I think I remember that. So we want to find the intersection between two of them. So the intersection is this place here. Let's call this X. So if this entire guy here is 22, then that means that the one of physics only, remember I talked about physics only, which is this guy here, physics only, this part here, if this all place is 22 and this small part is X, so then this place will be what? 22 minus X, right? And this place here, this whole place is 28 and this small part of it is X. That means that the mass only, which is this side there, will be what? 28 minus X. So if we now add all these guys, like this is physics only plus number of people that do physics and maths plus number of people that do maths only, if you sum all of them together, it should give us 42, because at least each student offers physics or mathematics. So if I wanted to sum this, I'll just say 22 minus X plus 28 minus X should be equal to what? 42. And if you do minus X plus X, this will cancel out, right? So 22 plus 28, this will give us 50 minus X is equal to 42. So if I carry over like term, so minus X will be equal to 42 minus 50 minus X will be equal to, this is minus 8, and if I divide both sides by minus, my X is equal to 8. So same answer but different approach. Either you want to use this formula approach or you want to use this Venn diagram approach, you will get the same answer at the end of the day. Let's see if our answer is even correct. So we have 8 students. Great. The second question says that out of 400 students in the final year in a secondary school, 300 are offering biology and 190 are offering chemistry. You see that there is no only year, so that is that entire cycle. How many students are offering both biology and chemistry if only 70 are offering neither biology nor chemistry? How many students are offering at least one of biology or chemistry? Let's solve it together. So what are we given in this particular question? Let's start what we're given. We're told that the number of students is 400. So the number in the universal set is 400. The number of people studying biology, so number of people studying biology is 300. and number of people studying chemistry is 190. So the number studying chemistry is 190. Now says how many students are offering both biology and chemistry? If only 70 are offering neither biology nor chemistry, so the number of biology union chemistry complements, right? Because they are offering neither of them, so it's the complement of B union C, and that is equal to what? 70, right? So we're told to find the people that are studying. So we're trying to find number of B intersection C, right? And we're told to find how many people are studying at least one of biology or chemistry. That is basically the number of B union C, right? So we're trying to find the number of people, total number of people that are studying either biology or chemistry or both of them. That is like saying N of B union C. Now let's solve it mathematically. Now our formula, right, from the formula that we talked about, our second formula says that what? N of U minus N of B union C complement is equal to what? N of A plus N of B minus N of A intersection B. The total number is 400, so this is 400 minus the complement is 70 is equal to number of students studying. Okay, I'm using A and B, so this should actually be B, this should actually be C, this should actually be B intersection C, so you can correct that. So the number of people studying B is, which is biology, is 300 plus number of people studying chemistry is 190 minus number of people studying both of them, we don't know that, so we can call it N of B intersection C. 400 minus 70 is what? 330. 300 plus 190, that is going to give you 490, and this is minus N of B intersection C. So if I collect like them, this will be 330 minus 490 is equal to minus N of B intersection C. So 330 minus 490, this should give you what? Minus 160. So minus N open brackets B intersection C. So if I divide both sides by minus, this will cancel, this will cancel. So at the end of the day, my number of B intersection C is equal to 160, right? So we know this. We found the first part of the question. The second part was how many students are offering at least one of them. So it's just trying to tell us B union C. We know from the formula that N of B union C is equal to N of A plus N of B minus N of B intersection C. We already know all of this, and this is N of A is I'm using this A again, so this should be B, this should be C, this should be B intersection C. Great. So the N of B is 300, so 300 plus 190 minus N of B, we've already found this in this previous question, should be 160. So that means our N of B union C, if I solve this, 300 plus let's do it simpler, 190 minus 160, that will give you 30. So 300 plus 30, that will give you 330. So the number of people that are studying either biology or chemistry or both of them, right? Like if you add all of them together, that should give you 330. Now if we solve it mathematically, let's solve it using Venn diagram. So using Venn diagram, let's say this is our B, right, which is biology. This is our C, which is chemistry. This is the universal cell, which is total number of people. Total number of people that we were told from the original question was 400. So our U is 400. Now we know the B to be, the B is 300 and the C is 190. So B is 300, C is 190. Right? Remember, this B is not biology only. This is the total number of people that are studying biology. Some of those people that are studying biology will also be studying chemistry. So people studying chemistry will also be studying biology. So this C here is this entire bracket. Now, if we were told that if this guy is the X, which is like the intersection, if I wanted to find people that are studying biology only, I'll remove those people that are studying chemistry. That will be 300 minus X. Same thing too. If I wanted to find people that are studying chemistry only, I'll remove those people that are studying biology. That will be 190 minus X. Right? We also told something that some of them don't even study any of them, and that is 70. So this is 70. Right? So by the time I had this guy, this guy, this guy, this guy, and this guy, right? So the people that are studying biology only, people that are studying biology and chemistry, people that are studying chemistry only, but those that are never studying any of them, it should give me 400. So that would be 300 minus x plus 190 minus x plus 70, right, should give me the total number of people, which is 400. So 190 plus 70, that will give me 260. Abi, 260 plus 300, that will give me 560. Minus x plus x will cancel out, so I'll be left with minus x is equal to 400. So minus x is equal to 400. Let's carry over this 560, so that will be minus 560. So minus x will now be equal to what? Equal to minus 160. Great. I hope you're actually solving this thing alongside me, right? And if I divide both sides by minus will cancel, then our x will be equal to what? 160. The same answer. Now that is for the intersection, so therefore we know that the intersection is 160. That tells us that we should find people that are studying either biology. I think the question was at least, yeah, so at least one of biology or chemistry. So these are people that are studying biology, these are people that are studying chemistry, these are people that are studying both of them. Remember I said at least is like one or more, right? So that would be 300 minus x plus 190 minus x. So for that would be 300 minus x plus x, what else again, plus 190 minus x. So this guy will cancel out. So we've said that before. 300 plus 190, that will give me 490 minus x. My x is what? 160. So if I subtract this will give me what? 330, right? So two different approaches, same answer. Left to me, I always prefer using Venn diagram because I like to show all those things, right? But any approach that you want to use is fine. Let's see if our answer is correct. So 160 and 330. Great. Let's see the next example. Example 3. It says 48 people went to a restaurant. 20 of them ate yam, while 18 ate beans. If 11 ate yam and beans, find out how many people ate neither yam nor beans. I want you to pause the video and try it out yourself. Welcome back. Let's solve it together. So what are we given in this particular question? The total number of people that went to the restaurant, that would be number of u is 48, right? Number of people that ate yam, let's say n of y, which is yam, is 20. People that ate beans, n of b is 18. If 11 ate yam and beans, so that is number of yam and beans, that is 11, right? How many people ate neither? So that is number of yam union b complement, right? So this is what we're trying to find. So we want to find people that did not eat yam or beans, right? And that is like the complement of it. That means like the opposite of people that ate yam or beans. Great. So if I want to solve this mathematically, I would say n of u minus n of y union b complement. You might not find this particular equation the way it is like this in other textbooks, but trust me, this works every time. So we have n of y plus n of b minus n of y intersection b, right? Great. So let's substitute. This is like saying 48 minus, so let's make this guy x, let's call it x. So this 48 minus x is equal to n of y is 20, n of b is 18, minus n of y minus b, this is 11, right? Substitute. So let's simplify. So 48 minus x will be equal to 20 plus 18, or let's say 18 minus 11, that is 7. 7 plus 20, that is 27. So if I take like them, that will be minus x will be equal to 27 minus 48. So minus x will be equal to 27 minus 48. If we do that, that should give you what? Minus 21, right? So our x is equal to 21. So if we check our answer, let's see if 21 is correct. Great. Well done. So the next question says that if the n of p is equal to 21 and the n of r is equal to 33 and the n of p union r is equal to 46, where n of p is the number of elements in set p, we should find the number of elements in p intersection r. So I want you to pause the video and actually try it out yourself. Welcome back. Let's solve it together. So in this question, what are we given? We're told that the n of p is equal to 21, the n of r is equal to 33, the n of p union r is equal to 46, and we're told to find the n of p intersection r, right? of course, if you're looking at this, the first formula that should come to your head is n of p union r is equal to n of p plus n of r minus n of p intersection r. Let's substitute. This guy is 46 is equal to n of p is 21, n of r is 33 minus n of p intersection r. That's what we're trying to look for. So p intersection r. Let's resolve. So that will be 46 is equal to 21 plus 33. That will give you 54. So 54 minus n p intersection r. If I correct like terms, that will be 46 minus 54 is equal to minus n open brackets p intersection r. So 46 minus 54, that should give you minus 8. Minus 8 is equal to minus n p intersection r. If I divide both sides by minus, this will go, this will go, this will go, this will go. So our n of p intersection r is just equal to 8. So that's it about the particular question. Let's see if our answer is correct. Great. So if you got it, well done to you. So let's look at this next example. It says in a class of 20 students, 12 play table tennis, 13 play cricket ball, and 3 are not allowed to play either of the two games. Find out how many students play both table tennis and cricket ball only, and table tennis only. I want you to pause the video and try it out yourself. Welcome back. Let's solve it together. First off, we need to put what we are given. The number of total students is 20, right? People that play table tennis is 12. People that play cricket is 13. So n of c is 13. And people that are not allowed to play any of them, that will be c union c complement, right? This is 3. So how many of them play both table tennis and that will be n of t intersection c, right? How many of them play cricket ball only? So that will be n of c. Then the way we represent is like saying only, right? Then the n of table tennis only, right? So this question mark. So another way of saying this cricket ball only is like people that play cricket ball but not table tennis. And table tennis only is like saying people that play table tennis but not cricket ball. So let's solve it and see. So we know our formula is n of u minus n of t union c complement will be equal to n of t plus n of c minus n of t intersection c, right? So let's substitute. This will be 20 minus this is 3 is equal to n of t is 12, n of c is 13 minus the intersection, which is n of t intersection c, which we're trying to solve. So 20 minus 3 is 17. 12 plus 13, that will give me 25 minus n t intersection c. So let's carry like terms. That will be 17 minus 25 is equal to minus n t intersection c. So if I subtract 17 from 25, I will have what? Minus 8. So minus n t intersection c. So if I divide both sides by minus, that means my number of t intersection c is going to be, so 8 people play table tennis and cricket. So we want to find people that play cricket only, right? So that will be n of c only, and that will give me n of c minus n of t intersection c. So I'm removing people that play both table tennis and cricket from people that play cricket, just like the way we always do in our Venn diagram. So how many people play cricket? This is 13. So that will be 13 minus 8, which will give me 5. Great. And how many people play table tennis only? Table tennis people are 12, right? So number of table tennis only, this will give me number of total people that play table tennis minus people that play table tennis intersection cricket, and that's 12 minus 8, and that gives me 4. So our answer should be if it's 5 4. Let's see if we're correct. Great, it's 5 4. If you got that, well done to you. In our final question, we're told that in a school 220 people offer biology or mathematics or both. 125 offer biology, 110 mathematics. How many people offer biology but not mathematics? Remember, we did not say anything about only here, so this is like total number of people, like that whole circle for biology and that whole circle for mathematics. I'll solve this using a Venn diagram. So in this particular question, what are we given? We're told that 220 study biology or mathematics or both, right? If that rings a bell, that should be n of b union m. right? Remember, whenever we have biology or mathematics or both, is always N of B union M. So that will be 220. Number of people that study biology, that will be N of B is what? 125. And number of people that study mathematics, so N of M is 110. So how many people study biology but not mathematics? Another way of saying this is like, how many people study biology only? Great. So if this is biology and this is mathematics, right, we're told that people that study this is 125, people that study this is 110, right? Alternatively, to instead of writing NB, I could also have said N of U, still the same thing, right? So if I wanted to, I could have said my U is equal to 220. Any way you want to choose is fine, right? So we're trying to find number of people that study B only, right, which is just this place here. So meaning that I first have to find the number of people that study both and then remove the answer from 125. So let's find number of people that study both first. So if this is X, this place will be 125 minus X. This will be 110 minus X, right? Just as always, we'll not say 125 minus X plus 110 minus X plus, okay, that's all. So this will be equal to 220, right? So this will cancel this. 125 plus 110, this is going to be 235 minus X is equal to 220, right? So minus X will be equal to 220 minus 235. Minus X will be equal to, this should give me minus 15, right? So X is equal to 15. So now people that study biology only should be 125 minus X. So biology only, that will be 125 minus X, which is 125 minus 15, and that gives me 110. If I was solving this with my mathematical approach, right, you know, I've said N of U minus N of B intersection M complements, but in this case it did not state anything that maybe something students offer neither biology nor mathematics, so that would be 0, right? So that will cancel out, and really that is really the solution to this particular question. Let's see if we're correct. Great. So 110. So with this, we've actually solved quite a number of examples that cut across almost all the things that you find in a two-set Venn diagram. I would advise that you keep on watching this thing. You watch, you solve, look for more questions to practice, right? You can only become perfect by practicing. So keep on practicing. And if you have any question, if you have any suggestion, if you have any feedback, please leave it in the comment section. And if you found this video useful, like the video and tell somebody about the channel. Remember, our goal is to reach as many people as possible. And I believe in the word of mouth. Right, so you tell somebody, somebody tells somebody, and that is how we're able to all grow together. In the next video, we'll be looking at Venn diagram shading for a 3-set Venn diagram. See you there.